Then everyone again with the new video which is the glycogen metabolism. So what it is? Glycogen is this? It is a polymer of glucose. Polymer of glucose. Okay. Now it have a amylose and amylopectin. Amylose having alpha 1 4 glycosidic bond, and amylopectin have alpha 1 6 glycosidic bond. Okay. This is the important thing. So we need to convert the glycogen from the glucose. From what we need in the previous video, gluconeogenesis, we seen the uh, breakdown of the any amino acid or the other things like any precursor which can convert into the glucose, like a pyruvate, how it convert into the glucose. So if you didn't watch, there is a link. Here is the link. You can watch this video by clicking this video. This is the second part of the carbohydrate metabolism. Now, so this all things will be occur usually in the liver. Where it is occurring? It is occur in the liver, and glycogen will be utilized for the glucose. Glycogen will be utilized for the glucose, and it will be supplied to the body only by the liver. Only by the liver. But muscles also can metabolize as a glycogen. Metabolism will occur in the muscles also, but muscles will utilize for the their self only. Okay, muscles don't supply glycogen to the all over the body. So three things we'll study in this glycogen metabolism. Uh, First, glycogenesis. What we are going to see? The first, glycogenesis. In this, if you'll see glycogenesis, we need a glucose. What we need? We need a glucose. So glucose usually is present in the form of glucose 6 phosphate. This glucose 6 phosphate will be isomerized. It will be isomerized into glucose 1 phosphate. Here it is isomerized by the help of what? Phosphoglucomutase. Phosphoglucomutase. So here it have to be activated. It have to be activated. So it is activated by UTP, means uracil triphosphate. Now it will give you the activated UDP glucose. What it will give? UDP glucose. or you can say. So finally, you will get the UDP glucose. This is the activator. So it will help in the binding of the glucose at the second prime OH of the of a glucose chain. So you have to follow this. What is the important thing? We need a precursor. We need a chain before binding this glucose somewhere. We cannot bind anywhere in this space. Okay. We need what? We need a chain. So the chain will be provided as a primer, and the primer is a unique thing. Okay, so till now we are studying the primer is required in the DNA synthesis only, but in glycogen synthesis also we need a primer. So this primer is made up of what? Is it made up of the nucleotide? Not, of course not, because we are going to add a glucose. So it is have to be made up of glucose. So there is a one enzyme which is called glycogenin. This is called glycogenin. So glycogenin will have the first carbon atom of the glucose. Okay, this is the first carbon atom of the glucose, and like that they have a 4 to 3, 4 to 5 carbon chain. Okay, so it is bound with the tyrosine here with this in early stage. Okay, and this is the reducing side. The carbon one is the what? Reducing side. Now whenever the new glucose will come, it will pass over this. It will pass over this and it will bind here as a C6. Like that it will go for the C7, and like continuously it will go, and they will form alpha 1 for glycosidic bond. So here you required one enzyme which is called glycogen synthase. Where what required? Glycogen synthase. And glycogenin is what? Glycogenin is a protein which is very important, which have a tyrosine end, which bind with the first carbon. It will actually it is uh, polymerizing the carbon shell till 5. How they are polymerizing, we have to go very deep to get it know, but for now it is enough. Till 4 to 5, like till oligomer 4 to 5 carbon chain, the glycogen will polymerize. Later on the glycogen synthase will start polymerizing the chain. Now this is the alpha 1 for glycosidic bond. It means it is a forming a amylose. So this is a chain only. Okay, simple chain. How we can make a branch? How we can make a branch? Make a branch. Now the question is that how we can make a branch. Anybody who can answer the question? There will be requirement of one enzyme again. What it is called? Branching enzyme. It is called. Usually it is called branching enzyme. Now what branching enzyme will do? Branching enzyme will cut the Branching enzyme will cut the 7 residues of carbon. Okay, what it will do? It will cut the 7 seven residue of carbon. Okay. Now this carbon will be transferred to the at least this carbon will be transferred at least this carbon will be transferred at least 4 residues, 4 carbon residue after nearby the end. Okay, so suppose there will be this many carbon, 1 2 3 4 5 6 7. So last four you will leave, this last four you will leave, and the last branch which is up to here, they came and it will branch somewhere here. Okay, now this will form a new branching chain. This will form a new branching chain. Okay, this will be the branching. This will be the alpha 1,6 glycosidic bond. Okay, this will be the alpha 1,6 glycosidic bond. So like this, the branching will be occur. The there is a name for the branching enzyme that is called amylo 1416 transglycosylase. It is also known as amylose 1416. 1416 transglycosylase. So I tried to make you understand in the very simplest way. If you have any doubt, you can ask me here, and we'll move to the new topic that is called glycogenolysis. You can get the link here also. Jai Hind.